Welcome to the Defense and Aerospace Report. I'm Vagan Maradian here at the Air Force Association's annual conference and trade show, Aerospace Cyber, the #1 gathering of U.S. Air Force leaders from around the world and indeed Air Force leaders from around the planet as well, joining us here at the Gaylord Convention Center outside Washington, D.C. Our coverage here is sponsored by L3 Harris and Leonardo DRS, and it's our honor to be talking to Major General Chris Azzano, who is the director of the Air Force Test Centers in their totality, whether the really cool tracks and rails that are out at Holloman all the way to Edwards Air Force Base, the home of flight test. And I should point out you're an experimental test pilot as well with, I think, 6,000 hours in 35 different types of airplanes?
It's about 3,000 hours and 35 different aircraft, and every one of them a joy to fly.
Absolutely, and I want to ask you kind of like, you have to ask a test pilot, and I'm sorry about the hours. I got confused there for a second. First, let's talk about the sprawling enterprise you oversee. It's 18,000 people. You guys have a very large budget, and in fact, you're busier than you've been in a very long time, both with capabilities that are coming into service now. For example, the F-35, an enormous amount of development work. You guys did a really impressive hypersonic test last week on the track at Holloman, where something flashes by in sort of a tenth of a second. Talk to us about the kind of work you're doing, the importance of that work, and how it's really feeding into virtually everything that the Air Force is doing right now as it works to get back up to speed on great power competition.
Well, the Air Force Test Center prides itself on adding value to the acquisition stream from basic scientific research all the way through capability integration on mature systems, all the way to developing and testing and evaluating brand new weapon systems as well. And as you mentioned, we have 18,000 people. We're spread across 32 geographic locations. We have large installations at Edwards Air Force Base, at Eglin Air Force Base, and at Arnold Air Force Base. And each one of them has a unique purpose, and each one of them is very well integrated, which is perfect now, because with the Chief of Staff's vision for multi-domain operations, we need to think less about airframes and more about the information and the mission sets and creating dilemmas on the battlefield for our adversaries that they just can't overcome. So as we look at it from a test and evaluation perspective, what that really means is linking the tremendous experience base and the minds and the innovation of our workforce to solve some of our nation's most challenging problems.
And talk to us about that, about the integration piece of it, because historically each of these pieces have sort of been done separately, whereas you're trying to do this in a very integrated fashion and actually conceptualize how to do stuff holistically far earlier in a program than doing a cyber applique later, have it foundational to a system, particularly if you're looking at, for example, hypersonic systems, where you want that surety and security across all the layers of what is a strategic deterrent system at that point. How are you bringing all of these disparate elements together, and how are you preparing your people to think cross-domain in a way perhaps that they weren't before?
Yeah, so we're known for our air domain excellence, and if you consider all the great flight test legends of the past, including people like Chuck Yeager, broke the sound barrier, there really is a tremendous history there, a tremendous legacy. We stood up the first cyberspace test group in the Department of Defense 2 years ago, with the intent not only to ensure future security of our systems as they pass large quantities of information back and forth, but also to make sure we bake those best practices into future systems. And we've got a tremendous team of professionals there at Eglin that are doing that. So when you take the expertise in network systems and passing those large quantities of information, doing it in a secure environment, and you integrate that with platform development, and then all the while with a focus on the end user, the warfighter, to make sure that the systems we're developing will be useful on the battlefield, will be relevant, will dominate our future adversaries. I like to tell folks that you're not going to find an organization that's better suited to doing that than the Air Force Test Center, because we have exceptional experience in the operational realm. We've got scientists, we have engineers, analysts, and we integrate very well with the operational community. And so we're able to look at those requirements and quickly assess where we need to go.
Let me ask you a manpower question, because right now, obviously, there's a retention problem for pilots. That's well known, and everybody's working to address that. At the same time, the Air Force is trying to attract the best and brightest talent, whether it's for combat air forces side of things, whether it's on the maintainer side of things, whether it's in the cyber skill set. But you too need some of the best and brightest engineering minds that the nation can produce. And ultimately, there is a question about whether or not the quality of the engineering talent we're producing is as good as some of our potential competitors at this point. And I know friends who've been in the flight test business have actually gotten out of it because for them it was getting a little bit on the mundane side. These are jobs that aren't in the limelight, but are still, you know, at least as a fighter pilot, you get a little bit of an accolade and everybody goes, oh, he's really cool, he's a fighter pilot. But for some flight test engineers who are going to spend their entire career, they're not going to be in the limelight, but their work is absolutely critical. Are you attracting the kind of talent you need? How are you making sure that you're attracting that talent? Because you're going to need it, and you're going to need more of it as we continue to develop even more cutting-edge systems at a time of increasing great power competition that folks don't expect to end anytime soon.
Yeah, obviously engineers are in high demand across the globe, and there are a lot of alternatives for them, and some of them are in the aerospace and defense industries, and a lot of them are not. And there are some very attractive and lucrative careers. What we find works well for us and I'm sorry to hear that you had an acquaintance that went elsewhere, but what we find is we bring engineers in and we show them the types of problems that we're dealing with. And they look and they realize this is an environment that actually values my innovation, actually values me thinking outside the box, actually values me adding value in new ways. And when we expose them to that environment, they tend to thrive in it and they tend to love it, and we keep them around for a long time. Another thing that we try to do, both out of our own necessity, but for their own development and for their own well-being, I guess, and professional satisfaction, is to move them around from project to project. So they can try a number of different things. Maybe one day they're doing a weapon development program, and another day they're working on some major airframe, or maybe
B-21, for example.
Maybe the B-21, for example. But there's such a diversity of things. At any given day, we're executing between 600 and 700 programs in the Air Force Test Center. And what we find is when we bring people in and they get excited about it, they want to stay. I mean, that's the whole reason I'm here after 29 years. The other thing that we do is we kind of shamelessly go out to the community and we try to foster a sense of importance of the STEM disciplines in our middle schools and our high schools, and when they see the importance of that, and they really get excited about what math and science can do for their future, they want to go off to the university and get their degrees, and then they want to come back, and some of them will come work for us. And again, once they see what they do and they see the excitement of it, and you know, the test pilots might be out there getting some of the glory, but when you look at the engineering team that stands behind that, and the analysts and the scientists that are making all of this happen, they're really a remarkable cadre, a true national resource. And I have seen them also earn and have bestowed upon them a great amount of glory and certainly the appreciation of their nation.
From an international perspective, you know, you mentioned about the national attributes of this, but if you look at it, some of our closest allies are working to try to solve some of the same kinds of problems we are, whether it's the United Kingdom, whether it's France. How do you partner and work with some of our closest allies who, you know, still have an enormous wellspring of highly innovative talent, engineering? They often need help from us, but sometimes they're bringing solutions to us. How are you working together with our closest allies, whether, you know, on the Europe side of things or in Asia, to make sure that we're all collectively on that razor's edge at a very important time?
Yeah, so obviously there's some highly visible defense cooperation initiatives, and we're always focused on building alliances, but it probably won't surprise you to hear that sometimes the best collaboration happens when we develop informal relationships early on. And one of the ways we do that in the test community is by bringing in some of our closest partners and training them in our own Air Force Test Pilot School. And they spend a year with their American counterparts in the joint services, and then they go off and they do great things in the international community. And it's not uncommon for us to seek out their help or for them to come to us and say, how would you approach this problem? So there's that natural synergy that really reaches back to relationships that are forged early in the careers of test professionals.
Everything is becoming more joint, fortunately. F-35 drove a more joint approach to testing that we saw in a long time, given that the jet is going to be in service with the Air Force, the Marine Corps, as well as the Navy, or I should say the Air Force, the Navy, as well as the Marine Corps, and more than a dozen of our closest allies. Talk to us about the joint piece of this, because the Air Force doesn't operate in a vacuum. Navy, Army, Marines have great technology. How at the end of the day are you working more closely with each of the other services to get the best and the brightest applied to solving some of the most difficult challenges without having to reinvent the wheel?
Yeah, well, that's one of the attributes we bring that we're most proud of, and it's the joint integration. And if you talk to anybody in the Navy test community or the Army test community, you hear a lot of the same vignettes about how we collaborate and how we try to leverage each other's best practices. It's very much a joint mindset, and it has to be, because every future battlefield is going to be a joint battlefield. And all that starts early on in the development of these systems, and we see that extensively. The F-35 is just one example of a program that leveraged the joint requirements, but the joint experience as well, to develop a world-class system.
How is technology changing how we test? Because anybody who knows flight test recognizes that when in the good old days it was flight test engineers or engineering flight test pilots, or experimental test pilots who were engineers rather, who were sort of plumbing, how is the airframe performing against what the original expectation was, whereas now actually we do it somewhat differently. The test pilot is testing the model to see whether the model simulated everything the right way around. So how is technology changing how you fundamentally test, and the amount of investment that's required, given that you need the best instrumentation, the best tools at the end of the day, whether it's in cyberspace or whether it's in physical space, to determine and test out the parameters of the systems that we're developing that are increasingly more complex?
Yeah, we tend to think about 3 to 5 years in advance of emerging technologies, and we have to, because when a technology is ready to test, that's not when we get started. We have to be ready when it comes to the test community. And so if you consider a technology like hypersonics, for example, a lot of really intense technology development, because the environment in which, for example, a hypersonic weapon will be operating is going to be one of intense pressure and temperature. And so we have to be able to test materials early on, and we do that in our environmental chambers and our wind tunnels. And then we do full mock-ups of vehicles, and we test those further in the wind tunnels. And then we do integration on an actual launch platform to make sure that all the systems will talk to each other and we can get a safe separation. And ultimately we test the vehicle in the environment it was designed to perform in. And if that means that we have to go someplace out over the water to launch a weapon hundreds of miles downrange, then that's what we have to do, and we have to be able to do that safely. So developing the workforce and the tools that the workforce needs to execute the T&E mission is one of our constant focus areas. But
we're back into a great power competition mode. I remember friends of mine who were initially associated with the F-117 program. It was always a race against a satellite, a Soviet satellite that was coming overhead to make sure that nobody saw the jets. So the flight test schedule was always baked around when orbits were going to go over so that nobody saw it. Now we're in a much more pervasive space and sensor and cyber environment. And once upon a time when we dropped stuff at the bottom of the ocean, nobody else could get it, whereas now other guys can get it as well, right? I mean, that used to be a domain that we dominated. How do you do some of this advanced testing in a way that the adversary cannot monitor it, glean lessons from it, and actually pick up some of your hardware that may end up someplace where you thought they might not be able to find it?
Yeah. Well, obviously it's hard to hide anything these days, right? I mean, it's there are sensors everywhere. Information is widely distributed across the internet, and it's very easy to observe from a variety of different positions. But we have a team that is very much focused on operational security when we do developmental work, and that may mean a physical security. It may mean cybersecurity. It may mean operating in an environment where we can look at pieces of information that are partially observable, and then other information, which is what we really need, which is not. And so we every step we take in the developmental community considers that important security piece.
Talk to us about the recent test at Holloman, which I believe set a new speed record. Am I right about that, or it must have come fairly close for a terrestrial landmark?
Yeah, so that test was actually a number of years ago.
Oh, I'm sorry.
It's a video that we saw as a demonstration, really, of some of the unique capabilities that we have. And it very quickly gathered a following, and we decided to put it online. And it's an absolutely amazing video that demonstrates some of the key test and evaluation infrastructure that we possess in the Air Force Test Center. That sled track can get you out well past Mach 6, 7 even, and to be able to put a payload on the end of that and test it in that environment is crucial to development of future systems.
And I apologize for misleading our audience. We were at DSCI last week, and I wasn't sure whether or not you guys had done another test and tried to outdo yourselves, although I remember covering all of the great work that was happening at Holloman, and I was also a fan of Colonel Staps. So anybody who would tie themselves to a sled and go that fast and experience that kind of G's and then hit the water and stop was always pretty impressive.
Well, he's a perfect example of the pioneering culture that is underpinning of the whole test and evaluation community. Do anything that it takes to prove a concept, a technology, a system to make sure that our nation is ready to fight and win the next war.
Let me ask you about you're a test pilot, 3,000 hours, 35 different types of airplanes. I know that asking a pilot what their favorite airplane was or the most interesting airplane was, what falls into the category of, okay, that's different, because I know guys have flown balloons, they've flown all sorts of other things. I think you may have flown a non-rigid airship as well. But walk us through your sort of top three, even if it was really bad, that you thought was like, wow, that's something.
Yeah, so you know, you talk about your first aviation love, and I grew up in the F-15E, the Strike Eagle. And to this day, I'm absolutely amazed by that airplane. I've gone into combat with it. I've done a lot of flight test work in it. It's a wonderful airplane, and it's near and dear to my heart, so that's probably number one. But I've had some great experiences in the F-16 as well. Also a wonderful airplane to fly and the mainstay of our tactical force. I did happen to fly the blimp at one point, the Goodyear blimp, which was unlike anything else I've ever flown, and absolutely fascinating the way it gets off the ground in a very impressive angle. I think it was almost 45 degrees, which is something that you generally only see in a fighter-type platform. I've flown the C-17, which is an amazing testament to our aerospace ingenuity to have an airplane that is that large and that capable, that is the workhorse of our mobility fleet, and the things that it can do are very impressive. And then I had the pleasure of flying the B-2 once as well. Again, an amazing testament to American ingenuity. And just a really neat airplane to fly because it handles differently from any other type of aircraft I've flown in that flying wing configuration.
But those are normal operational Air Force airplanes that don't have really weird, bizarre handling characteristics, unlike, for example, a blimp. What else falls in the category of, you want me to fly what? And you know, how you prepared for it, and at the end of the day, you know, whether you sat there going like, boy, that was something.
Well, it's interesting because as you go back in our aviation history, what you find is all the modern aerospace vehicles have great handling qualities because we've learned so many lessons over the years. So oftentimes you go back, you know, a few decades, and maybe you find a World War II or a 50s era aircraft, and you fly that, and you begin to appreciate the tremendous skill of our design engineers in these days, because those airplanes just didn't have the same flying qualities back then that they do today. And some of them were rather challenging to control, but also just fascinating and a lot of fun too. And a great way to develop a test pilot's skills is to fly an aircraft that doesn't fly well.
Major General Chris Azzano, who heads the Air Force's Flight Test and Evaluation Center. Sir, thanks very much. Really appreciate it. Best of luck, because you guys are doing very, very important work that I think, you know, it's not in the forefront of how people think about it, but we don't have that capability unless you guys develop it. So thanks very much.
Well, thank you. I appreciate your time today. It's been great. I'm very proud of our workforce. I'm very proud of the value we bring. We are exceptionally focused on the warfighter, and we are very proud of our status as one of the true innovation engines for the Air Force.